Good morning, students. Today we will discuss a new topic, Kepler's law of planetary motion. It is one of the most important laws. Its first law is law of orbit. It has three laws, but its first law is law of orbit. What is law of orbit? Suppose this here is a sun and any planet, suppose Earth, move in this around this sun in the elliptical path. So this is called law of orbit. This is called from here to here. This is major axis, and from center to here this is semi-major axis. Semi-major axis, and this vertical line is a minor axis. Minor axis. So law of orbit, it says that the sun is fixed at a point at one foci and Earth revolve around the sun or any other planet move around the sun in elliptical path. This is called law of orbit. So we can say that any planet move around the sun in an elliptical path, elliptical orbit, when the sun is at one focus. This is called law of orbit. And second law is law of area. Law of area. What is this law? Law of area means, suppose here is a sun, and if a planet move from here to here and then here and here, and it moves around the sun in elliptical path, but it sweeps out equal area in equal interval of time. When it reach here, then it also sweeps out equal area in equal interval of time. Because if planet is close to the sun, then its speed will become very fast, and when it is move far away, then its speed will be low. Okay, so if suppose here is area A with respect to time t, then here area should be A and time period will be t. So we can say that this is called the aerial velocity. The aerial velocity of a planet sweeps out equal area in equal interval of time. Suppose change in area and change in time is equal to constant. This is called law of area. Now next law is, third is law of period. Third law is a law of period. What is this? We know that this is a major axis, this is a minor axis in the vertical direction, and this from here to here, this is major axis, and from center to this point, this is semi-major axis. Suppose this is A, and here this is A. Okay, This is A, this is A, this will become 2A, and half of this will become A. Suppose the whole area is semi-major axis is 8. Then what will it become? Semi-major, it will become 4. So, square of the time period is proportional to the cube of the semi-major axis. Suppose this is 4 cube, then it will become is equal to root of 64 is equal to 8 period. So its time will become 8 periods. So we can say that law of area is the square of the time period is proportional to the cube of semi major axis. This is called law of period. So you have to do. So it has one numerical question number 1. Find the value of small g at a height 400 meter above the surface of earth. Above the surface of earth, where capital R is equal to 6400 kilometer and small g is equal to 9.8 meter per second square. Solution. Find the value of g at a height. We have already discussed g dash is equal to small g 1 minus 2h over r. Here r we have given radius small g 9.8 and g dash is the above the surface of earth. So put all the values and height h is so we can say that g is equal to 9.8, small h is equal to 400 meter, capital R is equal to 6400 kilometer, and now put all these values here. We get g dash above the surface of earth, g dash is equal to 9.8, 1 minus 2, h is 400 over 6400 is equal to 9.8, 0 and 0 will cancel out, 16, and here is 8, 1 minus 1 over 8 is equal to 9.8, take LCM, 8 minus 1 over 8 is equal to 9.8 into 7 over 8. Now remove this point over 10. We will also, calculating these values, we will find 5.87 meter per second square. This is the main result. What is the effect of height on acceleration due to gravity? Gravity के ऊपर height के ऊपर gravity का क्या effect होता है? Suppose Earth having radius capital R and mass m. Suppose a point here the gravity is small g. From above the surface of this Earth, it is g dash and at point B. Now we have to find out at point B what is the effect of gravity on the height. Okay, so we know that at point A, acceleration due to gravity small g is equal to capital G m over radius r square. This is equation number 1. At point B, g dash is equal to, at point B, g dash, suppose height h. At point B, g m over r plus height h whole square, equation number 2. Now dividing both the equations g dash by g, we get g m over r plus h whole square, and dividing by this we get r square over capital G m. This and this will cancel out. R square. Now take r with respect to r square outside and divide by r on both of these two terms. We get r square 1 plus h over r. R square cancel out. Here is 1 over 1 plus h over r whole square. So we will take upward side these values 1 plus h over r raised to power minus 2, then it will become 1 minus 2h over r. This is g dash over g. So therefore g dash will become is equal to g small g into 1 minus 2h over r. We can find out its numerical. G dash is equal to g into 1 minus 2h over r. So gravity decreases. So gravity decreases at the height.